there's a cool offshoot here, which is controversial, but super cool, and
Go
that is
for it.
that comb jellies. I don't know if you're familiar with these creatures. They're
Not intimately.
amazing looking. They look like aliens,
Okay,
and in
I'll have to
fact,
put one on the screen.
oh yeah, you may want to get a photo on your podcast. So they're incredibly cool looking, and they're
Okay.
really strange. And it's been suggested recently with some pretty good evidence that they actually evolved nervous systems independently from the rest of the animal kingdom. So they are
Wow.
really are kind of like aliens.
Like
Um,
jellyfish in some way? Is that the same thing that
they
happens
look
with
like
jellyfish?
jellyfish, but we're much closer to jellyfish than we are to them.
Wow.
So they had originally been grouped among jellyfish because they kind of look like jellyfish, although they're really strange. I mean, they move with this kind of like light pattern. They really look like alien spaceships. Um,
So cool.
and so it was assumed that they were part of the same group of animals as jellyfish. But then more recent evidence suggests they're actually much earlier offshoot from a time when there were no neurons. So we split off from them at a time from a common ancestor that did not have neurons. And so we came up with neurons, or our branch and their branch independent. And that's really,
You mentioned about the comb jelly. Was that what
comb
it was
jellies,
called?
yeah.
There's evidence that it evolved distinctly from all vertebrates and our nervous system. What would that evidence look like? I presume it's genetic, but does that just mean that the genetics is completely distinct? Like what does evidence look like when something evolves in a completely separate lineage to
Well,
us?
it has to do with comparisons across a few different branches. So sponges have no vestige, no evidence of ever having had neurons. So there's a
Okay.
fairly well established that sponges never evolved neurons, right? And then when you compare sponges and chordates, or so bilaterians, okay, which is us, right? Includes us and insects and gigantic numbers of animals, right? So bilaterians and sponges are more closely related than both of them are to comb jellies. Essentially, it means that comb jellies split off earlier than sponges. And at the time we split up from sponges, there were no neurons. And so from that, you can conclude that we developed neurons after we split off from sponges. And if the comb jellies split off earlier, well, then that goes for them as well. We don't know exactly when they evolved
Gotcha.
neurons, but it was far later. So I think it's that. It's essentially the comparison between those three groups that leads to that conclusion.
Very cool. Why is the jellyfish so unique? You brought up the jellyfish evolution. I've always thought this is so crazy that there's just an animal that's still, so common in the world today. I'm lucky enough to be a scuba diver and seen many in the wild, and they're just absolutely stunning, stunning creatures. They're amazing to look at, incredibly intelligent. But how do you get this secondary evolution of intelligence? Or I presume it's probably
Wait, you're
more
talking about the comb jellies.
I'm talking about the jellyfish here.
Oh, jellyfish regular. Okay, well, jellyfish
An
are closer
octopus.
to
Sorry,
us.
octopus, I mean, as well.
Oh,
So
octopus. Oh, yeah,
right.
yeah.
Octopus.
Yes.
Sorry. I misspoke there. Octopus, I mean, yes.
Yeah, so octopi are on a different branch from us. They're on the same branch as insects. And it's split off very, very long time ago from a common ancestor. There was nothing like an octopus or an insect or us or anything like a fish even, right? It was kind of like a flatworm, right?
Okay.
And then they went their separate way. We went our way. They went their way, and they they dealt with a complex world, and we dealt with a complex world, and we came up with various solutions to dealing with. Well, I wouldn't say solutions, right? Because that's not how evolution works. But we sort of stumbled onto mechanisms that allowed us to survive just as they did. And some of those mechanisms are the same. There's certain principles that are useful. So by then we were bilaterally organized, and they maintained it and we maintained that organization. So there's certain structures that could be compared, like again the hypothalamus and certain subdivisions within it. But the spinal cord is something that we came up with. Eyes, we had photosynthetic organs long ago, but eyes developed independently in that lineage with respect to ours. So And then, and then, like, since then it's been independent. It's like they came up with all kinds of, amazing mechanisms. And so have we. All right.
Right. Do we
You know,
understand
we
how?
don't need much about octopi, right? Because they are not helpful for my project, right? Because
Right.
they
Okay. Makes
on their
sense.
own, it's like it doesn't help me. I get a lot more of learning about, flatworms or the Amphioxus, because it's what I focus on is animals that split off and then didn't change so much, right?
Right.
So the Amphioxus is good, lamprey are good, birds are not so good because birds did a lot of innovation independently. I mean, birds are super cool and really impressive, but they don't help so much to understand mammals. And
Makes
octopi,
sense.
again, like, almost like an alien species.
Yeah.
Dr. Paul Cizek, what an absolute goldmine of information. If you enjoyed that short clip, then I'm so confident you're going to enjoy our full 2 hour long conversation, which basically covers the entire evolution of the human brain. You just have to click it here. You can click it right now, here.